Hello guys, in this lesson we will learn about more advanced web hacking techniques. So we look at mainly two types of attacks, cross-site scripting and cross-site request forgery. We'll see the process overview of both, and we'll see some different types of cross-site scripting, some process details in cross-site request forgery, and eventually we'll see an example of web defacement where we use tools like SQLMAP to do the work that we learned in the last lecture. So what is cross-site scripting? Before getting into the definition, let us see what it is. So usually there are either two parties or three parties involved in a cross-site scripting attack: an attacker, a vulnerable web server, and a victim client. Step one is where an attacker injects malicious code into a vulnerable web server. Step two is when a victim visits the vulnerable web server. So victim asks for something from this vulnerable web server, and to cater to that request, the vulnerable web server will respond back with a good response to the victim client. According to the web server, the response is a legitimate response with nothing wrong, but we know that the attacker has already injected malicious code into the web server. So what is served to the victim is a malicious code, and this malicious code is getting executed in the victim's machine because it has been executed on a victim's browser, and the malicious code executes on the victim's computer with web server privileges, and this leads to leakage of information to the attacker. To see a simple example, you can navigate yourself to this particular web page, games.samsclass.info. this page. This is for learning cross-site scripting. You can type your name and then you can go to the comments, another page, which is the next page, something similar to this. It's a comment section, and then you can type something and the comment comes, and you can also try to type in all these different scripts instead of random English sentences. You can try the same thing on this page itself. You can try the scripts instead of your name as well. So the first script alert XSS vulnerability. You can see it is a JavaScript code. So just like SQL injection attack, this script is getting executed as a script. So we are sending in the script as a random English sentence. So this sentence is considered as a input where they are expecting a string. But at the web server's end, this is seen as a script, and this script get executed. Okay, so you can see different attacks, like different types of script. This is a pop-up script which pop up XSS vulnerability. This one, for instance, is an alert which alerts the document cookie. It will take the document cookie and shows you the document cookie which is stored in a cookie file. And this is not something that you want in your system. So to explain this, the ability to execute arbitrary JavaScript in another browser allows the following attacks. Cookie theft. Attacker can access the victim's cookie associated with the website using document.cookie, send them to his own server, and use them to extract sensitive information like session IDs. Keylogging is another attack, where attacker can register a keyboard event listener using add event listener and then send all the user's keystroke to his own server, potentially recording sensitive information such as passwords and credit card numbers. Phishing attack is where an attacker can insert a fake login form into the page using DOM manipulation, set the form's action attribute to target his own server, and then trick the user into submitting sensitive information. So to broadly classify, there are three types of cross-site scripting attacks: persistent, reflected, and DOM-based attack. So persistent attack is where vulnerable application stores the attacker's code and present it to the visitors. Okay. Reflected is where there is no storing happen. So persistent is also known as a stored cross-site scripting attack. Okay. So the reflected is also known as non-persistent or reflected attacks, where there is no storage is happening, where vulnerable application simply reflects attacker's code to its visitors. So there is no storage is happening. In the DOM based attack, DOM is document object model. is a convention for representing and working with objects in HTML document, where a vulnerable application includes pages that use untrusted parts of the DOM model in an insecure way. Let us see one after another. First one is persistent attack. So it's 4-step attack in persistent cross-site scripting. It is also known as stored cross-site scripting, where attacker uses one of the website's form to insert malicious script into the database. So what the first step is, attacker browser will send a script to the database. So let's assume this database as a blog. So I go to a blog and I see that this blog is vulnerable to cross-site scripting. And in that particular blog, there's a comment section and I can comment whatever I want. So I put a script in the comment, and that is getting stored in the, when I submit that comment, that is stored in the website's database. Okay, the last comment. Then the second step is when a victim's browser go and visit the same website. So the victim is going to visit the same blog, but now this is not just a blog, it's a blog with my comment on it, my as in attacker's comment on it. The attacker's comment is basically a script. So now this page, when he visits, the browser says, the server says, okay, it's all good. Now the browser can render this web page for the victim. But what happens with the victim's browser is, this website includes malicious script from the database, right? So the victim's browser executes malicious script inside the response, sending victims cookies to the attacker server. So the sending victims cookie is just a figure of speech. It may not be always cookie. It could be something else. As we discussed earlier, it could be installing a keylogger, for instance. So what happens there is, victim's browser executes malicious script inside the response, which leads to loss of information or a launching of an attack. Let us just see a video on this, an example video on this, to understand how this persistent cross-site scripting happen in an example website. Okay.
This deeper dive covers cross-site scripting. There are two types of cross-site scripting: stored cross-site scripting and reflected cross-site scripting. We'll be talking about both here today. Stored cross-site scripting is a little bit easier to understand and explain, so we'll start there. Cross-site scripting is a scenario where an attacker can send HTML or JavaScript code up to an application, and then some way is found to get that same code down to our victim's computer. When that code is loaded into the browser, that's when the problems begin. Here's an example. This computer will represent our attacker, and this one over here will represent our victim. Frequently, cross-site scripting results in many victims being attacked. It could be hundreds, thousands, or even millions of potential victims. Stored cross-site scripting also requires a particular kind of vulnerable application, namely one where data is stored to a database somewhere, and then later pulled back from the database and sent down to the users. This could be something like an online web forum, maybe a blog, but it could be any application where data is sent to a database and then retrieved. Here's how it works. The attacker sends HTML or JavaScript up to the application instead of their normal input. This is then stored in the database and it waits there. Later, when our victim comes to the same website, they then download this HTML and JavaScript. So by using this vulnerable application as a starting point, we're able to attack every single person that comes to this website. The reason why this occurs is twofold. The first is that there are not proper input validation controls for input coming into the application. The second is that there are not good output sanitization controls for output going out of the application. Both of these issues combined are the reason why cross-site scripting works. Let's head over to our Hackers Bank application so we can see a demonstration of this. Okay, here we are back at the Hackers Bank application. Let's start by logging in as user 1. The post message functionality of the Hackers Bank application happens to have a stored cross-site scripting vulnerability. Let's click on the post message link. This functionality is intended to send a message to the administrator. So let's send a few messages. Let's start with something simple. Test, this is a test. We'll click submit. This message has been successfully posted. Great. Let's try something more advanced. In this case, what we're going to do is simply send some HTML to the application. And it looks like that was successfully posted. Let's try another one. In this example, we're going to submit a little bit of JavaScript. So let's use the script tag, and this time let's pop up an alert that just says "Hello World." Okay, so that's been successfully posted. So we're starting to get the idea that there's no input validation on this application. Let's try one last one. Okay, this one we're going to pop up a dialog box that has our cookie variable in it. Now we're starting to get into where this becomes a malicious activity. Once again, it was submitted without any trouble. Okay, so now let's log out of the user 1 account. And we're going to log back in as the admin user. Okay, so the admin user has the ability to view the messages. So let's click on the link. And we see that we've received a message from user 1, and it looks like there's a number of messages here. The first one comes right up and just says, "This is a test." That was the first one we did. If we click on the first cross-site scripting test, it comes back with the bold text just like we expected because we sent in header tags. If we click on the next one, this one pops up the "Hello World" dialog box that we submitted. That's interesting. Now, of course, this is only interesting as a proof of concept. Let's try one that's more interesting. Here we go. This one printed out the contents of our document.cookie variable, which in this case contained login attempts equals 1, role equals admin. Many applications also contain session identifier information in the cookie. If that were the case, the JavaScript could programmatically access it and send it off to an attacker somewhere else on the internet. What you've just seen here is a common scenario for cross-site scripting. It's not at all uncommon for a user to post a message knowing that an admin will look at it and submit JavaScript knowing that they will somehow be able to attack the admin account. Again, this is an example of stored cross-site scripting. In the next deeper dive, you'll learn about reflected cross-site.
So that is an example of stored cross-site scripting, right? So now let us move to the next type of cross-site scripting, which is the reflected cross-site scripting. So in the reflected cross-site scripting, to see how a reflected cross-site scripting works, you can move to navigate to this particular website. So when I say navigate to this particular website all the time, pause the video, go to the website, try it out yourself. Okay, so go to this website, and then you can type test and search. So when you search for test, it says that sorry, this cannot be found, test. It prints the particular word that you are trying to search will be printed as an output. Okay, So, and then probably you can search the following example, u test underscore u, and then what you say is the same thing, test with an underline. So what it means is that the script is not being input validated, and the browser tried to resolve it, and u is obviously an HTML tag, and the HTML tag is getting executed. Same here with the JavaScript is getting executed. So when you put script alert hello script, that will get executed. So why does this happen? So if you look at the source code of if you inspect this web page or look at the source code of this web page, you see that the problem happens at line number 37 and 50. Okay, in reflected cross-site scripting, the JavaScript payload is echoed back on the page returned by the server. If you look at line number 50 of the source code, you will see that the message that is displayed in the search result page is a string that is constructed using the query input value. So line number 50 says that, where is line number 50? Message is sorry, no results were found, plus query. The query is whatever you have typed in that box that you have, and the string is then passed to a function that renders the HTML output using the response in line number 37. So line number 37, self.response.out.s, right, as this string is just rendered in the HTML in the browser. Okay, so the problem is that the input is not escaped before it is rendered. So anything that you give as input in query, all of that will be rendered in the browser, not just a legitimate string. If you put a JavaScript here, this string and the JavaScript and the query, everything will be rendered by the HTML by the browser. So in reflected cross-site scripting, these are the 4 steps. Attacker crafts a URL containing malicious scripts. So if you know that there is a website which is vulnerable to reflected cross-site scripting, the first step is attacker craft a URL with the website containing a malicious script and send this to a victim. So how do you send this to victim? It has to be, can be a phishing email, it can be from the n number of social engineering techniques to send this particular URL to a victim. You can make it tiny URL so that the entire thing won't be seen there, etc., etc. So once that URL containing malicious script is sent to the victim is tricked by the attacker into requesting the URL from the website. So basically the victim is tricked into clicking that link. So when the victim clicks or visit that website with this particular malicious script along with it, the third step happened. Website includes the malicious script from the URL in the response, and the victim's browser executes malicious script inside the response, sending victim cookies to the attacker server. So victim cookies, as I said earlier, it's just a figure of speech. It may not be just cookies. It runs the malicious script that is returned by the server in the victim's browser, which can help the attacker steal information from the victim's system, victim's browser or victim's computer. Okay, so these are the 4 steps for a reflected cross-site scripting attack. In the above scenario, an attacker would need the victim to either visit any page controlled by the attacker. This might include an invisible iframe that points to the site that is vulnerable to cross-site scripting, along with a payload to exploit the vulnerability, or click on a URL link from the attacker. This link would include the exploit payload. In the example above, XSS query script hello. This is the example which we have seen earlier, and maybe obscured by a URL shortener. You can put this entire script into a URL shortener, shorten it, and then send it to the victim. It is worth noting that an XSS payload can be delivered in different ways. For example, it could be a parameter of an HTTP post request as part of the URL, or even within the web browser cookie. Basically, anywhere a user can supply input to the website. The final and the last but not least attack in cross-site scripting is DOM-based cross-site scripting. So if you go to this particular page, xss.docappspot.com, When you click each of these images, when you press image 1, you will see that the number over here will be 1. Press 2, image 2, you'll see the new image and the URL changes to hash number 2. And press here and you get image 3. So what we are trying to do is we are trying to embed our attack code here after the hash. We put the value, this value here, and when you run this particular page, what you see is you see an alert. How does this happen? This happens because we are manipulating the DOM. The XSS is triggered because the client-side script uses part of the window.location to set the inner HTML of one of the elements inside the page. Okay. When you go to the above URL, the location.hash variable, this variable over here is set to this particular string. So if this variable is set to 1, set to location.hash variable is set to 1, it will show the image number 1. If it is set to 2, it will show the image number 2, right, etc. But over here it is set to this particular string. And how does it affect? For that we need to look at the code a bit more closer. I will explain it in a minute. So if you look at line number 33, what you see is that you'll see that the substring of location.hash, the string after the hash character, is passed as an argument to the function choose_tab. So it takes that string and it is passed as an argument to choose_tab. Let us see what choose_tab is doing. In the choose_tab function, when you look at choose_tab function, it constructs an img element for embedding an image using the following instructions: HTML image plus pass in name, blah blah blah, etc. The HTML is created with the folder where the images are stored, which is static demos GECS, and the string, whatever string that is passed, which is .3123 in case of images, but we gave this string instead. So it is expecting 1, 2 or 3. That string .jpg, that's the name of the image, 3.jpg. So static demos G's 3.epg is the image name. So this is the HTML that is created in this choose_tab function. Okay, so when we change this name to something like this, a big function, big string like this, there is no such file that exists in the server, right? So it becomes something like this: image source equal to static demo GCS. Instead of being GCS 3.jpg, it becomes this big string image source x blah blah blah. But over here, this single quote and closing the so when you look at the string over here that we gave, the string that we gave comes with a single quote and a bracket, right? So this single quote and bracket completes this image function over here, which may not exist. There is no such image. And then there is another image source equal to x that also doesn't exist. So we get an error in loading the image. When we get an error in loading the image, it runs this function, this JavaScript function on error. It alert dom.xss. So that is how that alert comes in. The above is a valid HTML. However, the browser will fail to load the image and will instead execute the on error code. Okay, so when it's on error when an error happens, this code is supposed to be run, and this code is basically our malicious script. This image element is ultimately added to the document via inner HTML on line number 12. So if you look at the, look over here, it is document.getElementID tab content.inner HTML. So this DOM element of .inner HTML is the one which is causing all the problem, because this one is all created first and is added as an inner HTML element. Okay, so the number of steps in a DOM based attack is as follows. Attacker server checks out this site, this particular script, to the victim's browser. So attacker has to craft a URL containing the malicious script and send it to the victim. The victim is tricked by the attacker into requesting the URL from the website, same as reflected. And once the website receives the request but does not include the malicious script in the response, the victim's browser executes the legitimate script first, legitimate script inside the response, causing the malicious script to be inserted into the page. The victim's browser executes the malicious script inserted into the page, sending the victim's cookies to the attacker server. Now let us look at the next attack, which is cross-site request forgery. In cross-site request forgery, what happens is there are three parties involved, just like earlier: a victim client, a vulnerable web server, and an attacker web server. So first step is a victim is logged into a vulnerable website. So let's assume that your bank account website is a vulnerable website. So you are logged into your bank account, and that is a vulnerable web server. So you're logged in, you have transferred $100 to your credit card, etc. And then at the same time you decided to visit some page to watch something, and that page is an attacker web server. So that the second step, where you visit a malicious page. It's an attacker website. So this is the attacker website, which is a malicious page, and this is a bank account website that you have. So, and these are both in the same browser in different tabs. Okay, and at this point what happens is, when you visit the attacker web server is basically trying to attack this vulnerable web server. Okay, so from this web server there will be requests sent directly to this web server. So there's a script here in this web server which says send $1,000 to a particular account number. Okay, and that is running where? That is running on the victim's client, this client browser, the victim's browser. And the victim's browser, so that content is delivered to the victim's browser, which says send $1,000 to account number 11111. Okay, but when it is executed in the victim's browser, what happens is that the victim is already logged into this bank, and all the authentication is bank website, and all the authentication is given in the same browser. So the victim's browser has the privilege to send this to this bank account, to this bank site. Okay, so victim involuntarily, he doesn't even know that his browser is sending this message to say $1,000 to this particular account, sent to this account, and all the authentication is already there, and hence the transfer takes place. This type of attack is known as cross-site request forgery. So let us see an example demo with the same website that we have seen earlier. So go to testphp.vulnerableweb.com, login.php. When you try to log in, the username and password is the same, test for username and password, and you log in and you can see different details like name equal to John Smith, credit card, blah blah blah, all these things. So you can enter all so that is already there. You can change it. You can try changing this username and password, username and credit card number and street address, etc., and press the update button, and you can see that it gets updated. Update, log out, log in again, and you can see that whatever you have changed as reflected. Okay, so to bypass HTTP GET filtering prevention, we will use HTTP post to implement the XSRF attack here. So when you press this update button, it's an HTTP post request that is going from a trusted browser. So what we need to do is only just emulate this update button. This can be done using Burp Suite, or very easy technique is just download this page as is onto your own system, and then run it as a local copy, not the web copy. So instead of just emulating this update, you can emulate the entire page. So download this, save it in your desktop, open that. It will be like c/desktop/userinfo.php, and in that page, let me show you. In that page, if you change Bruce Lee name to Bruce Lee, blah blah blah, and then enter update, the update happens as long as you are logged into that browser, into that web page in the in another tab. Okay, so why does this happen? You can update profile information by using the above form in the your profile page. This page, if you look at the source code of the the source code of this login page, you can see this part where you can actually update your profile page. So for the previous code, we can identify the input fields in which will receive information from a user and send to a website. These are called UR name, UCC, UEmail, UPhone, and UAddress as shown below. When the user clicks the update button of the form userinfo.php, an HTTP post request will be sent that contains the above parameters along with their values. So you can just emulate this particular post request in your malicious website. What I did was a simple example where you can download the entire thing rather than putting everything in an iframe in a vulnerable website. Download the entire thing and then you run it on your system, and you can see that the information getting updated. Please test this out at home and let me know if it worked. You can host it in a SAM server and access it from another browser as a victim client and emulate the complete attacker website and vulnerable website at the same time. Or to make your life easy, you can just download it on your own desktop and just run it as a local copy. Okay, try this out and let me know if it works. It should work. It worked for me. It should work for you as well. If it doesn't work at times, it basically means that someone else is also playing with this website, and there are some settings that changed. It will get reset in a few hours and then you can test again. Okay, so with that, let us move on to website defacement. So website defacement is two things that we have learned already. We incorporate these two things to see how website defacement happens. So website defacement happens for multiple reasons. So as I said at the beginning of this lecture, it could be hacktivism, political hacktivism, angry users, just for fun, etc. So we'll use two things to do a simple website defacement. I'm not going to specify which website. I will let you do that. Choose that. There are two tools. One is SQLI Hunter, which can be used for finding SQLI vulnerable website. Mainly what it does is it uses different Google Docs to find vulnerable websites which are vulnerable to SQL injection. Then we use SQLMAP, which is a very powerful tool which automates SQL injection and database takeover. So all the steps that we learned in the last lesson, like where you need to find the vulnerable column and then find the tables in it, in the information schema, find the different columns in the table, etc. All these things can be done by SQLMAP automatically rather than you doing it manually. Okay, so we use these two tools to find a website to deface and try to we won't deface a website, try to get admin rights of that website. The step one is using Google Doc in SQLI Hunter. So you can use a Google Doc to find there are different Google Docs that are available in this, but we'll use this particular Google Doc. You can specify the number of results that you want. For in this particular example, I said 30. So it will show the top 30 website results that come with this, and then you start hunting. So it will show you all the different websites that are probably vulnerable to this attack. You may not find the same result because this is something which is done a few days back, so you won't get the same result. Some of them may have fixed their problems, and you'll get another set of lists, and from that you'll find the SQLI vulnerable links, and you select one of it to see if you can break it. So very easy to find an SQLI vulnerable link now, and the next step is use that to get that result. So we'll use the same test php vulnerableweb.com because I don't want to get into trouble. This is a website designed for testing out these vulnerabilities. We give sqlmap.py -u and give the website names and find databases. This command will probably attack this particular website and will give you the different databases available in this particular website. So you'll get accurate and information schema, and then you need to get the tables in that schema. So we'll look at -d acquired minus tables, which gives us all the different tables in this particular database: artist, cards, category, featured, guest book, pictures, product, etc. Same as that we have seen in the last lecture. Next step is to find columns in the table and username and password, to identify user account and username and password. The columns can be found by this particular instructions. Give SQLMAP.py, give the website link, give the database name, give the table names -t users, and then ask for columns. Once you have columns, you say declare the database, table users, -c column, whichever columns you want, email, name, pass, dump. So once you find the column names, give the different column values in each of these columns, you dump, and you will get all the different column values. So once you get to this point, you get the username and password to get access to this particular web page. So to summarize, we have seen persistent process scripting, reflected process scripting, DOM based process scripting, and cross-site request forgery, and at the end we'll see a web defacement example. The next lecture, it will be a lecture and lab together. It will be live. We will do hands-on experiment on buffer overflow attacks and format string attack to get root privileges from a vulnerable application. With that, thank you guys. Thank you for listening. See you soon.